Now let's solve the equation that you see here. You should know, you should really sit down and solve this and see if you can't identify all the laws that are used and everything that's actually done here. But assuming that you've done that, we're going to distribute multiplication by 2 and by 5. That is, we're going to use the distributive law of multiplication over addition. We can state that more fully, but you understand what's going on. The 2 distributes through here, giving us 6x minus 8, and the 5 distributes through here, giving us 10x plus 45. Again, check my arithmetic in these. You never know when I'm going to do something careless or even actually make a mental error. Then what are we going to do? Well, we could do this in one step or two. You see that our ultimate goal is to get the x terms on this side and the numerical terms on this side. How do we do that? We could add 8 to both sides. That's going to get the numerical terms all on this side. And we could add a negative 10x to both sides, which would get all the x terms over on the left. I'm going to do that one step at a time just to do it slowly. Now I'm going to skip the steps, but you should really understand that what's going on here is the steps I'm going to skip are negative 8 plus 8 is 0, which added to 6x is 6x by the inverse property and by the by the 0 property on addition. But I'm not going to belabor those points right now. I did that on a previous problem, and I'm just going to write what we have here. Okay, and that's just simplifying. But when we simplify, we're actually using rules, and there aren't that many rules. There's a small set of rules that we can use. Now, there are lots and lots of different ways we can use them, but the actual number of rules is just about something you can count on 2 hands. Okay, now what do we do next? Well, our goal is to get all the x's on this side and all the numbers on this side. So we're going to add a negative 10x. And I'm going to be stubborn and insist on adding a negative. Again, if you subtracted 10x, that's not wrong. I wouldn't count that wrong, but I want to illustrate that we can do all this by addition using signed numbers. Then, of course, 6x and negative 10x gives us negative 4x, and that equals 53, because the 10x and the negative 10x give us 0 and so forth. And then what do? Well, let's see, first of all, we added negative 10x, and then we simplify. Then we're going to multiply by what? Well, we have a negative 4x. We're going to multiply by its multiplicative inverse, negative 1/4. We get negative 1/4 of negative 4x equals negative 1/4 of 53, and I really didn't quite leave myself enough room, but we're going to get x equals negative 53/4. And that's going to be our solution to this equation. And I get a little careless there. Well, I'm going to just make things worse if I try to fix that. Anyhow, x is going to be negative 53/4. And of course you should substitute that back in here and make sure everything works. Okay, so we see that sometimes we have to use the distributive law. That should be no surprise to you. Now we get down to this equation, and this is where people often make the equation or the solution a lot more complicated than it really is. The simple thing that we can do here is we can multiply both sides by the common denominator, 66. Okay, if we look at these numbers from the previous chapter, the chapter on number theory, you know that the common denominator is fairly easy to find. You can do the prime factorizations and pick out the primes. You can use common sense, whatever. But we see that 66 is a common denominator. Now what most people want to do is put all this stuff over the common denominator. They don't really want to do that because, of course, that keeps everything in fractional form, and fractions are a little harder to deal with than what we ran into up here that didn't have any fractions. We had no denominators up here. So we're going to get rid of our denominators. We'll multiply by 66. We're going to do that a little bit carefully here because we want to be sure we're applying the laws correctly. We're going to multiply 66 on both sides. And then we're going to distribute. We're going to have 66 times x over 6 plus 66 times 3x over 11. Now, a very common error people make is forgetting to multiply the second term by whatever is being distributed through the multiplication. Of course, if you think about the fact that this thing is a multiplication, or that you are using a distributive law, you probably won't make that mistake, but I think everybody can testify to the fact that we all make that mistake sometimes. I certainly have, and I expect that you have too. So, being careful about the distributive law, we get this. And then 66 divided by 6 is 11, so we've got 11x. 66 divided by 11 is 6, so we have 6 times 3x. And 66 divided by 3 is 22, so we have 22 times 2, which finally gives us 11x plus 18x equals 66. Now that's going to be very easy to solve. I went through these steps partly to caution you about the distributive law, partly to show you that we want to multiply by a common denominator because that makes the equation a lot simpler than it was, and we don't have all these fractions to put over common denominators and all that unnecessary stuff. And also another caution is, do this one step at a time. You can divide 11 into 66 and multiply by 3 and get 18x, and I think, truly believe that you would do that correctly. You could divide this into this and multiply by 2. But I took 2 steps to do that, and of course I then, in the process, because I was talking while I was supposed to be thinking, I made a mistake, didn't I? I could claim that I did that just to illustrate that anybody can make a mistake, but no, it was an honest mistake. I wasn't really doing that on purpose. So, we see what we have here. And now we get 19x equals 44, so that x is 44 over 19, which is a perfectly valid answer. You should, of course, be able to change that into 2 and 6/19 if you need to, if there's a reason. But just to get the solution, this solution is equivalent to any other way you can write it, and it's in lowest terms, so it's a perfectly valid way to express the solution.